We know that our universe was started after the Big Bang, but we don't know how this universe will end or what will happen after the end of our universe. So, to answer these questions, Sir Roger Penrose introduced a cosmic model named as conformal cyclic cosmology, in which he tried to explain all these typical questions and also introduced few facts about this universe. So today in this video, we are going to understand this conformal cyclic cosmology. Before I start this video, I request you to subscribe my channel. As per anthropic principle, after the Big Bang, our universe evolved himself in such a way that intelligent life came into existence. And this principle is being carried out by second law of thermodynamics, which states that entropy or disorderedness of any system goes on increasing with time. So it is obvious that if we apply this law on our universe, then we are at a high entropy now, as compared to the time of Big Bang, which was at its lowest entropy. In Rogers' model, he told us that each universe triggers the birth of the next universe, and he termed each of these universe as aeons. All these aeons start with a Big Bang, and at the end converges to form the Big Bang of the next aeon. In Big Bang model, as you can see in this picture, it started and inflated in all three dimensions. Roger made some changes in this model and he draw it like this. Here you can see he expanded the Big Bang and converges the end of the universe. So how did he do that? As in Einstein's field equation, Einstein introduced a term called as cosmological constant. Cosmological constant is termed for the expansion of this universe, which is done by the dark energy. If you want to know more about cosmological constant, then click on the iCard. In Roger Penrose's model, it is essential that the expansion of the present universe should converge to form the Big Bang of the next aeon. But how will this happen? Suppose we have a cubical gas jar. I introduced few gas particles in one of the corner. After a while, you will see that the gas particles are expanding, and after some time, they will reach to their equilibrium point. Means there will be no further expansion. As per second law of thermodynamics, at the beginning, the system was at its lowest entropy, and after some time, the system reached its maximum entropy. There will be no further increase in entropy. At this point, if gravitational interaction starts to act between the particles, then all the particles will begin to attract each other, and finally, all the particles will accumulate at a single point. Now, if we apply this model on this universe, the point where I introduce the gas particles would be the Big Bang, and once the expansion is completed by the dark energy, this universe will reach its maximum entropy. After that, there will be no further expansion. Means the power of dark energy must be less as compared to gravitational pull. So, due to gravity, all the stars are going to attract each other and ultimately they will form a maximum entropy black holes, which will lead to the creation of next aeon. But here, don't mislead the term convergence. It doesn't mean the big crunch of this universe. The size of this universe would remain the same, and all the matters present inside this universe will accumulate to form a high entropy black hole. Here you may ask that according to cosmic microwave background, our early universe had very low entropy. But here I am discussing about a high entropy black hole, which will be the Big Bang of the next aeon. So it doesn't seem quite obvious. It violates the second law of thermodynamics, but actually it doesn't. When we say that during Big Bang our universe was at the lowest entropy, we say these lines on the basis of the matter present at that time. We don't include the gravitational field. So here we need to explain how this high entropy black hole is changed into a low entropy black hole. As per Planck's theories and cosmic microwave background's results, we concluded that our universe was uniform during Big Bang. Now I have to introduce a term, gravitational degree of freedom. It means movement of particles in all directions. So when all the matters were converging to form a high entropy black hole, it will concentrate every particle into a single point, means singularity, where degree of freedom will be zero. Hence, when there would be no space between the particles, gravitational pull's entropy becomes zero, and the only entropy which remains is the entropy of the matter. These matters are at a fixed position, thus their entropy is at its minimum. As the time progresses, the entropy rises. The uniformly distributed matters begin to clump such that all gravitational degrees of freedom are begin to be taken in all four dimensions, which will finally allow the stars and the supermassive black holes to form. Let's take a quick recap of what I have explained you. I was explaining the Rogers model, where he converges this expanding universe to form the Big Bang of the next year. After that, we applied second law of thermodynamics on this model to verify whether this law is applicable on this model or not. Then we discussed how the uniformity of the early universe leads to this chaotic universe. But till now what I have not discussed is how Roger Penrose expanded the singularity of the black hole. This can be easily explained by mathematics. As the model name conformal suggests, in mathematics, if any object is extended to infinity, there would be no change in position of the particles of the object. Such as if we extend a chessboard, you can easily guess the number of boxes in it and their positions. So similarly, we can extend the low entropy singularity point of Big Bang to infinity. But this method doesn't mean that you can extend the singularity of a black hole to infinity, because they have very high entropy of singularity. So guys, that's all for today's video. Still lots of arguments remain in this topic, which I will cover up in my upcoming videos. But before I end this video, I would like you to comment below what do you think, what can be the limitations of this cosmological model. Please comment below. And if you are still watching this video, then thanks a lot. Please like, share and subscribe my channel. So at last, thank you for watching.